Hey, good morning, guys. Happy Friday. We have Monday off, so that's wonderful news. I want to take you through page 196 and 197 in your review book using Table P and Table Q, and it's hugely helpful if you have these in front of you. One of the reasons why I love organic chemistry is because there are so many organic molecules everywhere, and thousands are invented or discovered every year. So pretty much our entire body, proteins, muscles, antibodies, organs are all organic molecules. The only thing that's not are bones, the water in our body, and teeth. Everything we consume is organic. Most medicines are organic. Most new discovery of medicines or vitamins are all organic molecules. So it's pretty straightforward. To the basics of organic chemistry is pretty fun. As you go into college, if you're interested in any sciences, you get into much more detail. That's when you get scared, but not now. Okay, so what we have here is Table P, and Table P just tells you the prefix depending on the number of carbon atoms. And we'll get into that a little bit more during this screencast. Table Q is what I really want to focus on today. So Table Q, hopefully you have this in front of you, has alkanes, right? And you don't have to pronounce them because I can't see you or hear you. Alkenes and alkynes. So those are called homologous series. So that's a big word, right? But it just is right here on Table Q. So alkanes are homologous of one another, meaning similar. Alkenes are homologous of one another, and so forth. Okay, alkanes, let's just start with alkanes, all have this general formula, CnH2n plus 2. Okay, I said there was no math, but there's a tiny little bit of math. Okay, where N equals the number of carbon atoms. So for example, what they did was they gave you the information on alkenes, the name and the general formula, and then they gave you examples. So this is an example of an alkane, alkyne, and so forth. So the example they gave you is ethane. So let me just take you through ethane. Let's go back to Table P above, and you can see Eth means it has 2 carbon atoms. So the reason this begins with Eth is it has 2 carbon atoms. The reason it ends in ane is because it's an alkane. Now, how do you know it's an alkane? Alkanes always have carbon single bonds. Okay. The other thing that alkanes do is they always follow that general formula up here. So if we plug in C2, because there's 2 carbon atoms here, and then we plug in the number of hydrogens we should have in this formula, right? So 2 times 2 plus 2, that gives us C2H6. So if we count up all the hydrogens here, we end up with C2H6. So all alkanes, all single bonded carbon with hydrogen will follow that general formula, CnH2n plus 2, if they're alkanes. So let's just do another example of an alkane. So how about if I give you C4H10? So I might ask you, is it an alkane, alkene, or alkyne? Now because when I look at this formula and I plug in 4 for the N, and then for the N again I plug in 4 because that's the number of carbon atoms, I would end up with 10. So this is certainly an alkane because it fits that general formula. If I was going to write it down, it's all single bonds because it's an alkane. I would start with drawing the 4 carbons in a row. Now because carbon has 4 bonding sites, all of those sites would be filled with hydrogen in this case. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is called butane. But, not but, because it has 4 carbon atoms. Ane, because it's got all, oops, I just made that a double bond. It's got all single bonds. So that's butane. Okay, and just to point out again, so carbon is always surrounded by 4 sites. So that's 4. This is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. It must be surrounded by 4 sites or it's just not a molecule. Okay, moving on to alkenes. Alkenes are really easy to identify with their general formula. If you look at their general formula, it is CnH2n, so it's just double. So if I said, okay, let's say we have 3 carbon atoms and it's an alkene, H would just be 2 times 3, which is 6. So that's an alkene. Let's say C5, you would just double it. That's an alkene. Okay, alkenes, and again, here's an example of ethene, again, because it has 2 carbon atoms. It starts with an Eth. And let me just give you another example. So let's stick with a 4 here. So C4H10. So I'm going to start by just drawing my 4 molecules like that. We're going to get into naming a little bit more, but for this class, we're only going to put a double bond in one spot. For now, it doesn't matter where we put it. But there I'm going to put it. So right now, it is an alkene, right? Because it has a double bond right there, double bond. So you have to be really careful when you're drawing your hydrogens, because I already have 2 bonding sites here on my first and my second carbon atom. So here I would only need 1 more hydrogen and then another hydrogen. So now I have a total of 4 bonding sites, 1, 2, 3, 4 with that double bond. On the second carbon atom, I already have 3, 1, 2, 3. So I would just need 1 more hydrogen. And it doesn't matter if it's on the top or the bottom. Your hydrogen, it can go anywhere, top or bottom. So let me just put on the bottom. And then my next carbon atom, I would draw 2 hydrogens around. And then my last carbon atom, I would have 3. So the more you practice, the better you'll eventually get here. This is kind of just an introduction. Okay, and then lastly, we have the alkynes, which have the triple bonds. So let's stick with the butane. Before I do that, let me just show you the example they have here. So again, alkanes, they follow this formula. You're taking away hydrogens because you have a triple bond and you can only accommodate 4 sites around the carbon atom. So you have to take away hydrogens. The example they give you again is ethyne, so eth meaning 2, and it has a triple bond. So let's do butane. Again, this will get a little bit more complicated as we move on. Not to worry you. And I'm just going to put the triple bond there. So I'm going to surround the first carbon with 3 hydrogens. Oops. So now I have 4 sites, 1, 2, 3, 4. My second carbon already has 4 sites, 1, 2, 3, 4. So I don't add any hydrogens. And then my next carbon also has 4 bonding sites, so I don't add any hydrogens. And at the last one, I'm going to add those hydrogens. So if I add up the carbons and the hydrogens in this formula, I end up with C4H, 1, 2, 3, 4, 5, 6. And then I must ask myself, does it follow that general formula right there? Well, let's see. C4 is my carbons. 2 times 4 minus 2 is 6. So yes, it does. So it's an alkene. So that's a little introduction, and we're going to get much more into naming. And your homework that is due is going to be a Google form. Have a great weekend.